we're on.
Yeah. Okay. Welcome everybody. Today is our 18th class, I believe. So first of all, put your name if you're not there, or tick if your name is in. So if your name is not there, so I can see quite a clean pic, just add your name, and the next time I will basically add you on. So first of all, my name is Tom Breza. I'm a host for C++ Londonini. Tristan, which just disappeared, is our main teacher, and obviously there's as well Oliver, who is now looking at us on YouTube, but is away on holiday. So first of all, thanks so much for coming. Mostly for the benefit of the new people, we are weekly free C++ classes, and you can basically be part of our group by joining us here or wherever we are, or online. Just go to YouTube and you can watch the class and participate in the class as normal. The reason why we do this is because we want to enable as many people as possible to get a chance to learn C++. So whether your life, work doesn't allow you, or even you're maybe a single person, you can't travel, we want to make it basically easy for you to basically get access to the knowledge of these guys. They're extremely experienced. We use in order to make the class as easy and easy to follow, and for you to basically go over the problems, we decided to use an IDE which is called Sea Lion. It's from company JetBrains. It's a commercial product for which basically people pay money, but because we did this as free of charge, it's a chargeable thing. JetBrains, offered us a 6-month license to all our students. So amazing thing. You don't have to pay for that. If you would like to have a license from us, first of all, obviously go to the website, download the software on its own. That gives you 30 days free for free. Then what you need to do is email me. That's my email address. Email me in a subject, put Sea Lion, and in the body of the email, put your name, surname, and email address. So I can just simply copy and paste, and I will email you a copy of the license. So that gives you 6 months of use. And as it happens, I have another batch a month ago or so. So I got plenty of licenses, so there shouldn't be no delay. If you want to have up-to-date information about what's going on, a couple of things. Follow me on Twitter, check our website, and obviously come to our classes. Our community sponsor, which is C++ on a C, it's run by Phil Nash. It's a really good new conference that's happening in February. You're very welcome to join them. If you want, you have to purchase tickets. Now is probably the best time to do it because they're advanced time, so you can buy those tickets at basically a discount. Now, today is the second class of object-oriented programming. It's a part of 4 weeks, so we're changing a little bit of approach from like main big courses to more streamlined, more let's say certain topic covering. Am I correct?
Yeah.
Yes. Very important. The classes on 11th September and 18th will not be happening at this location. They're busy. They can't have us. So we will be at Mimecast, which is literally, 200 meters from here. But for that, you need to book on our website. So as normal, you go to the Skills Matter website and you RSVP. For these 2 classes, you will have to book on our website because the Mimecast, it's a big company. They don't have booking facility, but we have to supply them at least day before the event with the list of names so they can print badges. So very important. If you turn up at the door, we might struggle to get you in. The insurance people will say, go away. Okay, so please do RSVP on our website. And our new course, yes, where we're starting from the most basic, will be starting on 18th of September, just a reminder. So if you're not experienced developer, if you don't have, and you'd like to get cover from the basics, mark the date, 18th of September. Tomorrow as well, we will be guest at CPP Chat.
It's tomorrow.
I think it's tomorrow.
Right.
I think it's tomorrow. So it's a it's plus podcast. It's news for some people. So yeah, so you can hear about us as well there. As mentioned, pick your name, and after the class, as usual, we're going to the pub. You're very welcome to join. Buy this guy a pint or two. Make sure he's fed, and before we send him home. And finally, at the bottom, as you can see, Tristan laptop unfortunately died. Tristan is doing an amazing job for us. He doesn't want to listen to that, but I'm not ashamed to say that. He's doing lots of good stuff for us, and we're trying to basically, ask our students to help us to get him a replacement laptop, because he's doing a great job, and as a way of our thank you to him, that's what we're trying to do. So if you want to help us, please do. If not, no problem. That's all from me. I'm passing to Tristan.
Okay. Well, good evening, everybody. Lots of new faces here tonight, which is great. Welcome, everybody. You have jumped into, as you can see, session 2 of our little sort of mini block on object-oriented programming. So we're quite a way into what we've done. We've sort of covered the basics, and now we had a session last week just sort of introducing some OOP ideas. We're going to carry on with that today, talk about inheritance and virtual functions in C++. So if you're already familiar with sort of Java or C# or maybe even Python, you'll probably be able to follow along. Today's mostly about the syntax and how you do this stuff in C++. But if you're just all at sea and you're lost and you've got no idea what's going on, then as Tom said, on September the 18th, we're going to be restarting from scratch, from the beginning. We're going to assume nobody knows anything about C++, and that would be a great place to start off if you're completely new to it. So by all means, listen tonight and follow along. But as I say, if you just feel completely lost and what on earth is going on, then 2 weeks' time, not here at Mimecast, it's a company in Moorgate, as Tom said, a couple of 100 metres up the road. We'll be there, and that'll be a great place to start off again. What else? Yes, Tom's already mentioned this, but there's this new conference it's run by a friend of ours. Got a really good lineup. If you are interested in going along, then you can go to this website. They're doing early bird tickets now. Highly recommend it. It's going to be great. Yes. Moving on again, because we've got lots of new people today. Usually I just race through this one, but I'll mention it. We have this. You're probably all familiar with Slack, right? Anybody who's done any sort of programming, everybody uses Slack these days. It's a chat room type program. The CPP language has their own Slack, and we've got our own room in there with this snappy UG_UK_CPP London Uni name. Needless to say, we didn't pick that, but that's just their naming scheme. Anyway, I recommend everybody go and join us on there. If you go to this URL, there's a little box just to type in your email address, and then you've got a little captcha to fill in as well to prove you're human. And they'll send you an invitation to join the roughly 2,000 people on this Slack. And then you can chat to us, you can chat to other students, you can chat to people who are following online, and discuss anything you want to discuss. For example, plastering walls, which is what people were talking about over the weekend. But usually we talk about C++ as well. So this is today's agenda. We're going to do just a little bit of revision from last week. Going to go over it quickly. We're going to talk about inheritance in OOP, inheritance in C++ is what I meant to say, class inheritance in C++, and virtual functions in C++ as well. So let's dive straight into it. So we started talking about object-oriented programming last week. OOP, for those who I imagine most people have sort of heard the term but don't necessarily have an exact definition in their head. Would that be, is that a fair thing to say? Oh, okay. Everybody knows exactly what it means. I find it very hard to define exactly what it means. I've tried to come up with a meaning for it there. We sort of model the world, model whatever domain we're interested in, as consisting of objects, concrete objects, which interact with each other in various interesting ways. And in particular, in OOP, we say that objects have state, they have actions, methods they're normally called in most languages, which modify that variable state, that object's state. So in C++, we model the state as the member variables of our class, of our struct, and we model its actions, its methods, as member functions. So again, if you're familiar with Java or C# or something like that, this is pretty much exactly the same. In fact, Java sort of took the OOP bits of C++ and simplified the syntax and threw all the complicated bits away and really just kept all the OOP syntax of C++, and then C# kind of just copied Java, basically. So one thing we were talking about last week is this idea of encapsulation. This idea that objects should be, in some sense, self-contained. That you shouldn't just arbitrarily be able to go in and change an object, go in and change an object's state. All state changes should happen via that object's action, via its methods, via its member functions. And again, this is a very familiar notion to all. This is not C++ specific. This is a general sort of object-orientated programming principle. And to support this, C++ gives us these things called member access specifiers, member access restrictions, which can help us enforce encapsulation. So this is what we were talking about last week. So, for those who were here last week, how many member access levels do we have in C++? 3, very good. And what are they? Public, private, and protected. Fantastic. Right. What is public member access?
It's available to the public.
It's available to the public, yeah? And by the public you mean?
All other objects can use it, yeah.
Any other code, yeah, absolutely. It means that if we have an object of type T, it means that any other part of our code can call T's member functions and can access its public fields if we have public fields, which is probably a bad idea, but it happens. So that's public members. What about private?
Means nobody, like no code can access it other than the members within the same class.
Perfect. Perfect definition. Yep. So private members can only be accessed from within the member functions of the same class. So private means inaccessible to the whole of the rest of the world, except these classes' own members. This class's own members. And finally, the third one was protected, which means what? Sort of halfway between public and private. What is protected?
The same class and derived classes.
Brilliant. Everybody's way ahead of me. We'll be finished in half an hour. Yeah. So protected members can be accessed by the same class, so like private members, but also can be accessed by member functions of derived classes. So you can think about it that the functions that you declare as public, that's the public interface of your class. That's the functions that the whole of the rest of the world can call. And the protected members of your class, that's the interface that you present to derived classes. Now, we didn't get on to talking about derived classes last week, but that's going to be mostly what we're talking about this week. And just finally, what's the difference between a struct and a class in C++?
Different between what, sorry?
Sorry?
Between what, sorry, again?
A struct and a class.
One is a public one, and one is private.
One is public and one is private. Sorry?
don't remember which one.
Which way around there?
I can't remember.
Could you repeat the question?
What's the difference between a struct and a class in C++?
Structure public, class of private.
Yes. So in C++, if we define a type with a struct keyword, it means that everything inside it by default is public. And if we use the class keyword, it means everything inside defaults to private. But we can override those defaults just by putting the keyword in. So structs and classes are almost exactly the same thing in C++. So some languages, C#, for example, D, Swift, structs and classes are quite different things. But in C++, they're basically identical. And in fact, I will often use the words struct and class quite interchangeably. So when I say class, I mean types you declare with the struct keyword as well, and vice versa. Right? So the only difference is in the defaults. Everything you can do with a struct, you can do with a class. Everything you do with a class, you can do with a struct. There's really no need to have both keywords in there. I don't know why C++ has both of them, but they do pretty much exactly the same thing. We happy with all that from last week? You seem to be. That was really good. So public, private, protected. These are things most OOP languages have. Something that's a bit more unusual is the word friend. Friendship. So what does the keyword friend do in C++?
It's a relation between class and class, isn't it?
It does define a relationship, yeah. What's sort of from a language perspective, what does it actually do?
Access to the private member function.
Protect.
Primarily for the logging or debugging.
Or whatever, yeah. So we can use the friend keyword. We write friend, and then we write the signature of a free function, a non-member function. It means that the implementation of that function has access to all of our private class members. So C++ is a bit unusual in having free functions, non-member functions. Java, C#, or maybe C# does, but Java certainly doesn't have non-member functions. But C++ does, and we can use the friend keyword to give these functions access to all our private stuff. A very long bullet point, this one, isn't it? Wow, I should have broken that down into a couple of them. But anyway, essentially when we do this, when we say this thing is a friend, it means that that function becomes part of our public interface. So free functions are always public, non-member functions, anyone can call them. And because anyone can call them and they have access to our private members, they are in the same category as our public member functions. So we usually use them in situations where the C++ syntax requires us to use the non-member syntax. So the most common example of this is when you write an output streaming operator. So an overload of operator, arrow, that streams to an output stream. So again, if you've been doing this class for a while, we've done a couple of examples of printing out class types. So that's one of the most common uses for friend. We can also use the friend keyword to declare that an entire other class is our friend. This is a bit more unusual. Really doesn't. It's useful, but only if you're doing kind of hacky things. If you're trying to be too clever sometimes. But we can declare that a whole class is our friend. And when we do that, it means that the other class, all of its members, can call our private functions, can access our private members.
Isn't it just better to make that function part of the same class then?
Usually, yes. So this thing about making a whole class a friend usually turns up when you're messing about with templates and you want to make a whole family of templates friends of your class. So this is a bit more advanced. It's just there so that you know that this functionality exists. If it were to turn up in a test, that might be happening in a couple of weeks. Oh yes,
Sorry.
yeah.
I'm going from Java. And
Yeah.
Different object-oriented programming, but this friend is looks like really very confusing for me because we never have like a friend in different places. We have like a protected one where every other like team in one package can get access to it.
Yeah.
So why are they having friend here now? Is it to get in access for outside their package or something?
Well, C++ doesn't have a notion of packages, right? Or modules or anything like that. So the public, private, and protected work exactly the same in C++ as they do in Java. But in C++, we also have these functions that don't belong to any class. So in Java, every function, every method belongs to a class. In C++, you can have functions which don't belong to classes. Right? So like C functions, they just exist on their own, and you can call them, yeah, like C. Yeah, exactly like that. And this friend keyword allows you to say the implementation of this non-member function, this free function as it's called, is allowed to access my private members. That's what the friend keyword does.
Well, that is against what you were calling about cohesion, where every object is
Yes,
sort of
yes.
itself.
Effectively, this punctures a hole in encapsulation. Right? This is not something you should do broadly. This is something that's used in limited circumstances. Right? It's to, like I say, punctures a hole in this protection that C++ gives you against accessing members. Right? So we only do it in very limited circumstances. Usually, as I say, there are some situations where we have to use the non-member syntax, and that's usually where we use friends. And this notion of making a whole other class a friend of yours, don't worry about it for now. As I say, this is pretty rare. You only really use it for pretty advanced things. So if you find this notion, this bottom bullet point really confusing, then don't worry about it too much. So that was, in 2 slides, what we talked about for 2 hours last week. Get out of the way.
Can we access the presentation slides somewhere?
Yes, they are. Last week's are on GitHub. I will write down the URL. When we go on to do an exercise, I'll write it on the board and you can access all the slides from last week. Also, we are broadcasting live on YouTube right now, and we last week's presentation, so this from last week, is available to watch on YouTube if you want to go back and read that. Read that, watch that, listen to that. Okay. Any questions from last week's material? Other than being confused about what friends are. I know I'm a C++ programmer, I don't have many friends either. All right, let's talk about inheritance. Now, most of you already seem to have quite a good idea about object-oriented programming, which is great. So you probably already know what inheritance is. So perhaps somebody can tell me, what is inheritance? What does it mean? When we say class A inherits from class B, what does that mean?
When it inherits all the values and methods of one class to another.
Mm-hmm. Yep.
Only the public, not the private.
Well. We'll get on to that. Because as with most things in C++, inheritance is a bit more complicated than it is in a lot of other languages. Right? C++ is just complicated. I mean, I'm trying to make it simple, but the reality is it has a lot more features than most other languages. But you don't have to use most of them. You just kind of have to be aware that they exist in order to sort of avoid them and just keep doing things the simple way. So today I'm really going to be focusing on what's called public inheritance. There are other types of inheritance that I'll mention briefly. But anyway, back to talking about, just in general, what inheritance means. Sort of very loosely, if we inherit from another class, we're building upon that class. We're extending it in some way. So again, very common notion in many programming languages that have notions of object orientation. And when we inherit from a type, we call the type that we're inheriting from, we call it a base class. Some languages call it a subclass. In C++, we tend to call it a base class. And in turn, we can have, that base class can have base classes of its own, which can have base classes of its own. And we can form this big, long chain, what we call the inheritance hierarchy. So we can have a BMW class, which inherits from car, which inherits from vehicle, which inherits from, I don't know what the superclass of vehicle would be, but you get the idea.
So that's better than putting, say, structs inside structs or classes inside classes.
You mean as like a member type?
Yeah.
No. No, that's not quite doing the same thing.
But it replaces doing that.
No.
Okay.
I'll get on to exactly why.
Sure,
Yeah.
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 You talk about home exercise.
Homework.
Yeah.
I can do. I will get to.
Some people on YouTube start,
Why aren't you talking about the homework?
asking. Yeah.
Okay, right, yeah, fine. I will at some point. Then I'll find a place to talk about it. Okay. Where was I? Yes, virtual functions. So we can declare certain functions, certain member functions as being virtual, which means that we can override that functionality in a derived class. We're going to talk about that in the second half of today's lesson. So the slides will be available afterwards. Just, or you just want a picture of me and all your, yeah. So how do we actually declare? When we're writing C++, how do we declare that a class inherits from another class? Well, first of all, we write our base class. I could have used this keyword struct there, would have meant more or less the same thing. And then we write class derived, so our derived class, and then we put a colon, and then this mysterious access specifier thing, and then the name of the class that we want to inherit from, followed by the actual class definition, as usual. So in Java, C#, this is the same syntax, except you've got this mysterious access specifier thing.
Extends.
Oh yes, sorry, yes, you're right, extends, yes. So this access specifier thing, we already know what access specifiers are. They're public, private, or protected. So this reuses these keywords. And technically speaking, it's optional. We can leave it out. But it's generally a good idea to put it in. Because if we leave it out, then this is the second difference between class and struct. So if we use the word struct there, and we omit the access specifier, then we get public inheritance. And if we write class, and we leave the access specifier out, we get private inheritance. So there are two differences between class and struct in C++. The first one is that structs default to public access, and classes default to private access. The second is that structs default to public inheritance, and classes default to private inheritance. Structs public, classes private. So I've already mentioned this, but just to put it in writing. Other languages that often talk about subclasses and superclasses, which is terminology I always find confusing, because in general the subclass can do more than its parent class, so shouldn't that be the super one? I don't know. I find subclass and superclass a bit confusing, maybe just because I don't use it very much. But in C++, the usual terminology is to talk about base classes and derived classes. So this one might come as a bit of a surprise if you're used to Java. So in C++, we don't have any sort of distinction between base classes and interfaces. In fact, there's no such thing as an interface as a language feature in C++.
Do you not have abstract methods?
You do have abstract methods. We'll talk about those later on.
Is that because C++ supporting double inheritance?
It's exactly because C++ supports multiple inheritance. So what we can do is we can actually just have a class that has nothing but abstract methods in it, and that functions more or less identically to the way an interface functions in Java. Right? So it's got no member data of its own. It's just got an interface for us to implement. It's got public members that are all abstract for us to implement. And that works in exactly the same way as an interface in Java. But there's no language level distinction. Another thing that might be a bit surprising if you're used to Java is there's no root object. So in Java, there's java.lang.objects. C# has, oh yes, system.objects. There's NS_object if you're used to Cocoa. Python, I think everything inherits from objects, or used to. I think it might have changed now. But in C++, we don't have one of these. We don't have a root object type. Which means that generics templates are implemented quite differently as well. But that's a topic for another time. And finally, as you were saying, in C++, we're allowed to inherit from multiple base classes. We can have multiple inheritance. This is maybe not the best feature for a language to have, at least not being able to inherit from multiple classes that have data members can cause you some problems. It's something a lot of people recommend against, having multiple inheritance, and that's why when they were designing Java in the 90s, they got rid of this idea of multiple inheritance and instead said, okay, you can have one base class and implement as many interfaces as you like. C++ says, okay, we're not going to have interfaces, we're just going to have classes, but you can inherit from as many classes as you like.
Tristan,
Yeah.
I'm going to go back to the concept of private class, like the way you inherit. It's like if you use the keyword private.
Yes, we're going to talk about that quite a bit in the next couple of slides. Because public, private, and protected inheritance is very weird.
Yeah, I mean,
Yeah,
it's the strongest.
it's
Private is the strongest.
We'll get to it. We'll get to it. In fact, we'll get to it right now. We've got not just one type of inheritance, 3 types of inheritance. Public, private, and protected. Of that, what we really want, what's useful, what we like, is public inheritance. When we talk about inheritance, when we say class A inherits from class B, what we mean is public inheritance. That's the good one, that's the useful one. That is 99, probably more than that, 99% of the time, public inheritance is what you want. Right, so when I said the access specifier is optional, that's true, but you almost always want to write public in there. So, just to very briefly tell you what private inheritance means. It means, from a technical sense, that all the public and protected members of our base class get put in our private section. So only our member functions can access those public and protected members of the base class. And in a sense, this can mean that our base class, that our derived class has a copy of the base. Not very useful distinction, not a very useful way of thinking about it, that one, or not to me anyway. Better way of thinking about it is that the inheritance, because it's private, because the outside world can't access this thing that we're inheriting from, it means this inheritance is just an implementation detail. And there are specific circumstances where you want to do this, but they're pretty rare and they're pretty advanced, and they're when you're trying to do really clever things like trying to minimize your memory usage. Almost all the time, it's better to have a member variable. Rather than having private inheritance, you want to have a member variable instead. So this slide is basically to tell you there is this thing called private inheritance. You probably don't want it. Use a private member instead. Next, we have protected inheritance. Now, there are occasions where private inheritance can be useful if you're doing advanced stuff. In God knows how many years of doing C++ now, I have never, ever, ever found a use for protected inheritance, right? I had to look up exactly what it means, and this is what it means, apparently. I don't know what protected inheritance is useful for. I don't know why it's in the language, but it is. So there you go. You can do it. Why? I don't know. But it exists. So let's talk about the good one. Public inheritance, the thing you want. When we inherit publicly from a base class, it means that all of the things that are public in the base class become public in our class. So if a base class provides a method, a member function, a method, then that method is usable, is public in our class as well. And all the protected members of the base class are protected in our derived class as well. This is good. This is what we want. So we say that public inheritance models and is a relationship. So the example I was using earlier, BMW publicly inherits from car. So a BMW is a kind of car. And a car is a kind of motor vehicle, say. And a motor vehicle is a kind of vehicle, right? Not the same kind of vehicle as an aeroplane, but it's a kind of vehicle. And this means that when we write a function that is expecting a vehicle, we can give it a BMW, because a BMW, in a very literal sense, is a vehicle. So public inheritance it's the normal kind of inheritance we're used to thinking about. It's what other languages give you. And we almost always mean public inheritance when we talk about inheritance. The other two, one has very occasional use, the other has no use whatsoever. But I just wanted to make you aware that they exist. One common error that I actually still do quite a bit is I forget to write a class, a colon, and the base class name, and I forget to put public in there. And then the compiler gives me an error like, you're not allowed to access these base class members. So if you see that, it's probably that you've forgotten to put the word public in, so you've defaulted to private inheritance. So let's have a look at a little example to see if we can make this a bit more concrete. There's been a lot of me waffling.
Sorry, even if you use struct
Yes,
and you don't put a public,
you're correct. If you use struct and you don't put public, you've defaulted to public inheritance anyway. Right. So there's a good argument to saying just use the word struct everywhere.
Yeah, very good.
Yeah. And in fact, here I have used the word struct. So we've defined this struct animal, and we've given it a member function called eat that takes no arguments and returns nothing. We haven't defined this member function, we've just declared it. And now we've declared another struct called mammal, which publicly inherits from animal. So this is saying that a mammal is a kind of animal, which I hope is factually accurate. And then we've got this member function called getNumLegs, because apparently I forgot that whales and dolphins are mammals when I wrote this. Well, they could just return 0, right? Anyway. And then we've defined another kind of animal called a bird, which has another member function called flap wings. So what's the relationship here between mammals and birds?
Birds inherit from animals, of course.
Yeah.
But between mammal and stuff, they are on the same level, aren't they?
Yeah.
Both of them.
There is no relationship between a bird and a mammal. They're both kinds of animals,
Yeah.
but you can't use them interchangeably, right? So the idea behind this public inheritance is to say whenever we're expecting an animal, we can pass a mammal or we can pass a bird. But we can't pass a bird where a mammal is expected, and vice versa. Now, we can go even further. We can define our nice struct dog. Dog is a kind of mammal. It's got this nice member function called sayWoof. A dog is a kind of mammal. And a mammal is a kind of animal. So it's the transitive relationship. A dog is a kind of animal. So when I say that object-oriented programming is good for modeling the real world, I'm not kidding. This is, this is about as real world as it gets, I suppose. A dog is a kind of mammal, is a kind of animal. And if you wanted to, you could have like an intermediate base class. You could have a four-legged animal, maybe. And you could have a cat that's a kind of four-legged animal that's a kind of mammal, maybe. So these are our class definitions. I've used the keyword struct just to avoid writing private in each of them. Save space on the slide.
Sorry, so the functions inside,
Yes.
they will sit within animal or mammal, alright? So say wolf would be within mammal, that would be a member of mammal.
No. sayWoof is a member of the dog class, right? So only dogs can say woof.
Okay.
Birds can't say woof. Mammals can't say woof. Only dogs. And equally, a mammal can't flap wings because that belongs to the bird class and things that publicly inherit from a bird.
But all of them can eat.
But all the animals can eat. Yes, absolutely. Right? Because a dog is a kind of mammal, it's a kind of animal, which means that from in a technical sense, this inherits from mammal, publicly inherits from mammal. So this getNumLegs function becomes a public member function of our dog class. And a mammal is a kind of animal, which means that this public member function becomes a public member function of mammal, which means that it becomes a public member function of dog. So it doesn't look like it here. The dog actually has 3 public member functions. It has sayWoof, it has getNumLegs, and it has eat. So let's just see a little example. I've declared this main function. I've created a dog called D. Or should have called it Rover or Fido. Sorry.
Why did you have the public?
Here, mostly just because I said earlier it's a good thing to put it in. So you're absolutely right. I could have omitted the public word there and it would have worked exactly the same way because structs default to public inheritance. So we've got our dog, whose name is D. I wish I called it Fido or Rover or something, but I didn't. I call it D. And we can say D.sayWoof, because sayWoof is a member function of dog. And we can also say, Rover, how many legs have you got? It'll probably say woof. But that's okay, because a dog is a kind of mammal. And we can call this member function on any kind of mammal that we like. And we can go even further, as you were saying, every mammal is a kind of animal. Every animal has an eat function. So we can say d.eat. We can call the eat member function of our dog. What we can't do, however, is try to say, dog, flap your wings. Because unless you've been doing horrible genetic experiments, dogs don't have wings, right? A dog is not a kind of bird. Because bird doesn't exist anywhere in this inheritance chain, as we call it. So the inheritance chain goes dog, mammal, animal. None of those are birds. Therefore, it doesn't have this flap wings member function. So does that make sense? I think people seem to have, yeah.
I'm just coming to this from a readability perspective. It seems that I have to spend a bit of time following, because some people might want to put the dog under the, they might have a different flow. So I'm just, what is best practice in terms of the flow of the code?
It's not just best practice, it's a requirement. So you remember C++ has this very awkward thing that you, in order to be able to use a function, you have to have declared that function literally in the source code above where you use it. And it's the same when we're doing inheritance. In order to be able to inherit from a class, the compiler must already have seen its definition. Its definition must appear literally above where you use it in the source code.
Yeah.
So these things have to exist in this order. Well, you could flip those two round, but
Yeah. Okay.
yeah. But what you'll usually do is you will have one header function for each class. So if this were a slightly more realistic example, we'd have animal.hpp, and then we'd have mammal.hpp, and bird and dog, and so on. And at the top of that header file, we'd hash include the other headers that we need. So that, if you remember the hash include, it does a literal copy and paste of that text. So that would automatically place the animal definition physically above the mammal definition in the source code. So again, if you're coming from Java, this idea of include is like, it's from the 1970s, and it's an embarrassment that we're still stuck with it in C++. It's a real shame, but they are trying to do something about it. But we live with it, and somehow we manage to write programs that are.
What is it? Sorry, I haven't followed. What is hash? I mean, is it including the whole code on top of the?
That is exactly what it's doing. So in C++, we have this distinction between header files and implementation files. So if you've written any C, you'll already probably be familiar with this. So you put the declarations of your functions and of your classes in a header file, and that header file gets reused in many places. And then you put your actual function implementations hidden away in a different file. Early in the course, I think week 2 or week 3, I went into quite some detail about this. I haven't really got time to go into a lot of detail about it now, but if you come back in a couple of weeks, we'll talk about it again. But yes, this is a kind of prototype. There are two examples everybody uses when they're introducing object-oriented programming, right? It's either shapes or animals. So this time you've got animals. Maybe next time I'll do shapes. Animals are nice because you can do these intermediate classes. But if you're familiar with another language, be it Java, be it C#, this notion is probably familiar. I mean, you use a colon and public rather than it extends or inherits or whatever the word is. But the idea is very similar. Swift, I think, uses this same syntax, albeit without public. And this idea that you can call your base class member functions, again, it's hopefully pretty familiar. So any questions about this before we move on to things that are a little bit more complicated?
Are you going to cover
Virtual functions, you mean? Yes.
now?
Well, I'm going to talk about constructors and destructors first, but yes, that's.
If you want to do multiple inheritances, you just chain them on the public.
Yes, where did I get to? Yep, so what you do is you put a comma, and then you do another access specifier, and then the name of the next base class. Comma, access specifier, base class. We're going to talk more about interface classes, that is purely abstract classes, next week, when you'll see a lot more examples. I just want to keep things simple for the first week. I'll work my way through this slide again. Bear with me.
Question.
Yeah.
You know, in some of the classes where you do on the base class, you do some initialization of some properties.
Yep.
In Java, when you go to a subclass, you do a super when you're calling the
So how do you call a base class constructor?
Hmm.
Yes, that's an interesting question. It's exactly what we're talking about now. Yeah. So again, another bit of terminology. We can think about having a base class subobject. This is sort of terminology that turns up. And the way to think about it, and actually literally what happens, is that when this is laid out in memory, you have your struct, or your class, and it has members, might have an int and a float and a string. The memory for each of those is sequentially laid out. When you have a base class, oh no, right, draw this on the board instead of waving my hands in the air. Sorry, Tom. Right, so we've got our struct base, contains an int and a float. Now we've declared the second struct called derived that inherits from base. And derived contains a string. And the way you can think about this being laid out in your memory is, if you imagine your computer memory is laid out in a whole load of cells. How many do I need? 1, 2, 3, 4, 5, 6. And when we construct an instance of base, what happens is that this, it reserves 4 blocks for our I, because an int is 4 bytes in size, and the next 4 blocks for our member f, because a float is also 4 bytes in size. Usually, it doesn't have to be. So our struct base will be at least 8 bytes in size, right? And because these are nice 4 and 4 is kind of a nice size for computers to deal with, they really like powers of 2. So our struct base is probably going to be 8 bytes in size. You can leave spaces in the middle because that allows for faster memory access in some cases. In this case, it won't do that. It'll just have those. So this is what happens when we construct a base. Now, we've said when we create a derived is a kind of base. So everywhere that we can pass an instance, everywhere that we can pass a base object, we have to be able to pass a derived object. And in particular, that means that derived needs to have a copy. It needs to contain an I and an F. So our memory layout for our struct derived, I'm just going to go on and on and on and on. It's going to look something like this. It's going to have an I, and it's going to have an F, because it has those members. It's inherited those members from the base. And then it's also going to use some memory for the string. It will use more than 4 bytes, but this is just an example. So let me change to a different color. So this part, the I and the F, this part within our derived, that's called the base class subobject, right? Because the memory layout for within derived is exactly the same as it is for base, right? So in a very literal sense, an instance of a derived contains an instance of base.
Is it a copy of the base class, or is it a reference? Just a reference.
It's a copy. It contains an instance of base. Right?
So let's use your standard copy constructor to do that.
Well, we can decide, right? So we've literally got a copy of base hidden inside here. So when we create an instance of derived, we have to create an instance of a base first. Because we contain a base, so we have to initialize that class. The way we initialize classes in C++ is with constructors. So we have to ensure that our base class subobject is properly constructed and properly destroyed. So our base class constructors are called before the derived class constructors. Because if you remember when we were talking about constructors, I said all of your member variables get initialized, get constructed before your class constructor runs. And it's the same for base class subobjects. And when we destroy things, C++ is very, very strict about the fact that things are destroyed in the reverse order that you create them. So when we destroy an instance of derived, it's first going to run the derived destructor, and then it's going to run the destructor for each of derived member variables, and then it's going to run the destructor for base, and then it's going to run the destructor for each of base's member variables in the reverse order in which they're declared, because it's the reverse order in which we constructed them.
Sorry, if we are trying to now removing the drive, destructing it.
Yeah.
Will it destruct the C and I and F in the drive, but doesn't go to the base one?
So the order in which things will be destroyed,
S first,
it will destroy S first,
and then F
and then it will destroy our base class subobject.
Yeah.
So in C++,
there.
well, in C++, we can define functions called destructors that run when we destroy an object. So it'll call the destructor for our string, then it'll call the destructor for our base class. And as part of the destructor for the base class, it will destroy the int and the float. Now, int and float are built-in types, they don't have destructors, but if these were like user-defined types that had destructors, they would be called as well.
That was my concern. If there is several derived classes and we call one of them, so we should
so if
not.
this one had its own base class there, then that would be called as well, right? C++ always calls destructors for you. You cannot avoid it. Right. If this thing about lifetimes in C++ is pretty complicated, and we've again spent quite a bit of time on it in the course, but we will definitely go over it again in a few weeks' time. So, yes.
So to use your animal example,
Yes.
if you construct the dog,
Mm-hmm.
that would take out dog and mammal.
Yep.
But it would not touch animal because you still have bird.
No. So.
That was my concern.
Okay. So there are two different notions here. There's this idea of defining a class and an object of that class type. So we don't destroy classes. The class is the definition in our source code. We destroy objects. Okay. So when we destroy an object of class dog, it runs the dog destructor. Then it runs the mammal destructor. Then it runs the animal destructor. That always happens, and you can't avoid it happening. That's built into the language. Automatically cleaning up.
Sorry.
Yeah.
I try to. I mean, if we have a mammal one,
Yeah.
okay, one base class, and then we're creating two subclasses, let's say mammal and bird.
Yes.
Okay. And then we creating a dog as you did.
Yep.
So we remove the dog. Does
Yep.
that remove the dog, the mammal, and the animal? And that kill the bird doesn't have a superclass because
No, it's not removing the definition of the class from our program.
The objects.
It's removed. So a bird has a copy of the mammal, whatever the mammal data is.
Oh, so they
Inside
are
it.
separate. So they,
Yeah.
Okay.
So it literally has a copy of the mammal data inside it. So when we destroy a bird, it first of all destroys the bird data, then it destroys the mammal data, then it destroys the animal data.
Oh, for that.
For that instance of it.
Yeah.
Yes,
No,
for
that's-
that particular
That
object.
makes sense. Yes.
This is one of the reasons you don't use new anymore.
Um,
If you're defining something all over the place and trying to remove it manually, it can be enough.
it's a problem, and we're going to talk about this next week. We're going to talk about smart pointers next week, and virtual destructors as well, which again is a peculiar thing to C++. But we'll talk about it next week. But anyway, as we were talking about, before we talked about destruction, we were talking about construction. And this notion that derived literally has inside it a copy of a base. Or if you prefer to think about it in the example, a dog, an instance of a dog object, an instance of the class dog, literally has inside it a copy of all the data members of mammal, and inside mammal is a copy of all the data members of animal. So in order to handle this properly, when we construct a dog, we've got to call a mammal constructor. So this is about how we, syntactically, how we actually write, when we're writing our constructor definition, how we call the base class constructor. So again, like you said in Java, you use the word super to initialize your superclass. In C++, we use this thing called the member initializer list, which, if you've been coming to these classes, you'll be familiar with it, using it to create your class members, to initialize your class members. We also use it to initialize our base classes. So here I've defined this class called base. I've given it a default constructor, a defaulted default constructor, in fact. And then I've given it another constructor that takes 2 ints. Doesn't really matter what it is, this is just an example. So again, if you've been coming to these, you should already hopefully be familiar with constructor syntax. Constructor is like a special kind of member function that has the same name as the parent class and doesn't have a return type. So now we've got our class derived, publicly inherits from base. And I've given derived a default constructor. And now this is the magic bit. This is a constructor initializer list. So we had these for initializing our member variables. We also use them for initializing our base classes. So this is saying, when you construct derived with no arguments, I want you to call the base constructor and pass it, in this case, 3 and 4. So this is calling this constructor here. And then this constructor has an empty body. There's nothing else to do in this class. In fact, the class is finished.
Can we call off a delegation in that case?
What do you mean by delegation?
You mentioned the delegate.
Delegating constructors.
Yeah.
You could have derived calling another derived constructor, which in turn created base. You could do that. So this is, when we did the delegating constructors, what we were doing was calling another constructor from the same class. What this is doing is calling the base class constructor. And in particular, it's calling this base class constructor. And what this means is by the time we get inside these brackets, by the time we reach the body of the constructor, our base class is already fully constructed and available for use. All of its member variables have been initialized. Whatever this constructor does has already happened. So we don't, in the body, you don't have to call super, you don't have to do any initialization. That's already happened by the time we reach the body of this constructor. Now in this case, we could theoretically omit this line. This line, we could take it away. If we did that, so this line starting with a colon, if we just deleted it or commented it out, what do you think would happen?
Error.
An error.
It would be defaulted to 0.
The default. Go to the default. Supposed to do. Because we call it default that.
In a sense, it would be nice if it gave you an error. It would. I think it would be quite nice if it forced you to choose which base class constructor you want. But it doesn't. If we were to remove this line, what it would do is it would call the default constructor of base. So if you don't tell the constructor which base class, don't tell the compiler which base class constructor to use, it will use the default constructor of your base class. But what if the base class doesn't have a default constructor? Then you get an error. Then you get an error. So if this default constructor didn't exist and this line didn't exist, then it would be an error if we tried to create an instance of derived.
So we're expecting to
Yeah.
initialize it with the two numbers.
Exactly that. Yeah. Perfect.
Could you initialize it in base with giving default numbers in the int?
No, you can't. So imagine this had two members, I and j. You would not be able to directly set I and j here. It must be done via the base class constructor. Come on. Yes.
In the previous slide, we talked about the constructor.
The destructor, yes.
Yeah, destructor. I personally have not used C++, but I use Java. Is it the same as garbage collector?
No, so that's quite an important difference between C++ and Java. So there's no garbage collection in C++. There's no garbage collector.
Okay.
So what happens is that when a variable goes out of scope, when we leave, the control leaves the block in which we declared it, then that object gets its destructor run immediately. It's something called deterministic destruction. So if you use Java, you're probably familiar with finalizers, right? Maybe? All right. Well, Java has these functions called finalizers that run, the garbage collector calls it when it cleans up your class, when it cleans up your object, I should say. And finalizers get run after a sort of indeterminate period whenever the garbage collector feels like it. At some point in the future, it's going to delete it when you finish with it. C++ isn't like that. C++, you know exactly when your objects are going to get cleaned up. Again, it's a very big topic to sort of go into now, but we're going to be talking about it an awful lot when we start again in a couple of weeks' time. Well, not in the first lesson, but in the first couple of lessons, we spend a lot of time talking about object lifetime in C++.
What does default? Does it mean something?
This equals default.
Yeah.
Yeah, so this is a special syntax that we can have for default constructors. It just says, I want you to call the default constructor of each of my members, please.
Have you defined default anywhere? Or?
Well, this is sort of built into the language.
Yeah.
Yeah, and what it does is it just calls the default constructor for each of our base classes and each of our members. Now, base doesn't have any base classes and it doesn't have any members,
Yeah.
so actually it does nothing.
Okay, so if for like JavaScript, would it be equivalent to null?
I don't know enough about JavaScript to answer that. But I mean, this is a valid function. It's just a function that does nothing because there is nothing in this class that it needs to initialize.
Could you change it so that it's an error, so that if it gets called, it produces a certain type of
You
error?
absolutely can. And all you do is change that from equals default, you change it into equals delete.
Okay.
And then we're deleting the function, and then any attempt to call that function is an error. Or we could just get rid of it entirely. We just comment it out, and that way we'd be forced to use this constructor instead. So yes, if you don't tell the compiler which base class constructor to use, it will try to use the base class's default constructor. If the base class default constructor doesn't exist, then you'll get an error saying, I don't know how to construct one of these things. So about references. I'm going to talk about pointers as well. If you're a Java person who's scared of pointers, look away now. They're not hard in C++. But they're a little bit unfamiliar if you're only familiar with Java. So this bit is actually still probably quite familiar to you. If we have an instance of a derived class, we can form a pointer, or forget about pointers, we can form a reference to its base class subobject. So the way to think about it is in this little diagram again. An instance of derived literally contains a copy of a base object. Literally, a derived object literally has a base object inside it. So we can get a reference to this base object.
Instead of copying it for each object.
Instead of copying it. Exactly that, yes. And we can then call the base class methods using that reference. So in this example, perhaps I should have called them cat and dog or something, but not cat and dog, dog and animal. In this case, our derived class literally contains an instance of the base class. So we can form a reference to that, what's called the base class subobject. So to give you an example, continuing with dogs and animals, we're creating a dog called D, and now we're forming, this is read as a reference to an animal. We're naming this reference A. And we're initializing it from our dog. Dog is a kind of animal. Our dog instance, D, contains a copy of an animal inside it. Whatever animal data there is inside our instance of dog contains a copy of all the animal data, and this is forming a reference to that. So then if you remember from our example before, animal had this member function eat, and we can say a.eat. We know all animals can eat, so now we've got an animal reference, and we can say a.eat.
So why do we need to say a.eat? We could supposed to be saying d.
You could say, you absolutely could say d.eat.
Yeah.
So why is this useful? It's useful because we can write a function that takes an argument that's a reference to an animal. Yeah.
So, because you initialize A with D, does A now have access to the members of the methods of D, or does it lose the access of?
No, it doesn't. So this is saying A is a reference to an animal. All this knows about is the animal interface. It doesn't know anything about mammals or dogs whatsoever. So if we tried to call a.sayWoof, it would go, that's an error. I don't know. Animal doesn't have a method called sayWoof. So returning to why this is useful, we can write a function that takes as an argument a reference to an animal. Okay, and then we can call that function with a dog or a penguin or a zebra or any kind of animal we like. And when we're writing the code in this function, we don't have to care what kind of animal we've been given. Right? All we care about is that it's an animal and it can eat. So in this little example just here, it's not very useful. But when we come to write functions that act on these references to base classes, that's when things get really useful. And then it becomes even more useful when we have virtual functions. But we'll talk about those in a bit.
So why don't we put those functions inside the class of the animals itself? So why do we need to write them outside and give a reference to them to the animal? To the base class again.
Because this All right, imagine we had a class called Carnivore. And Carnivore has a method called eat, and you give it the kind of animal that you want it to eat. Right, so you have, there's a class called Carnivore, and there's a class called Lion that inherits from Carnivore. So Lion has eat, and then in brackets, you give it a kind of animal to eat. So you can say lion.eat zebra, or dog, if you want to feed a dog to the lion, which is a really bad example, but you know, I'm making this up as I go along. So you would be familiar with this in Java already. It's just a slightly different form, because you would say like interface something equals new class. Right? So in Java you might say shape S equals new square, and that's creating an instance of a square, but only accessing it through the shape interface. Okay, that's exactly what we're doing here. So we're creating an instance of a dog, but now we're only accessing it through the animal interface.
So you're not assigning a reference address of D. So you're not.
So A is a reference to this bit. It's the base class subobject.
Base class subobject. So if you updated D, it wouldn't change.
It would, yes, because this is a reference.
Yes,
right?
That's what I
So if we change animal there to dog reference, then anytime you change D, you change A, and it's exactly the same.
If it was animal,
You don't change.
it's
if you change-
higher up.
Right?
You don't change like if you change anything in animal, then that doesn't change anything in A.
Do you mean if we change something inside the dog?
No, like if we make a new class, animal A is animal A, or animal A B or something. Or no, we just no, okay, that doesn't make sense.
Okay, so if you change dog, yes.
Yeah. So within our instance of dog, there is an instance of an animal. Right? So if we change that animal instance that's inside the dog, then that's going to be visible through this reference.
Okay,
This
so
is literally a reference to the animal that's inside the dog. The animal
that's tied into dog because of the ampersand.
Yes, precisely.
So if we change the base class now, which is the animal,
Yeah.
will that reference be updated without
Yes.
changes?
Yeah. So,
See what I
You
mean?
can't change
If you have created several
change
animals.
A or D.
What's that?
You can't change animal. Can you? You
No,
just
but
change
if
A
you're
or D.
adding something to the animal,
do you mean
As a
changing
base class.
the class definition?
yeah,
Yes. If you change the class definition, then that would change the definition of D.
Then what's the point of having a reference to the D instead of just having it to the base class?
Because we can't call say woof on an animal. We can only call say woof on a dog. Because only dogs can say woof. This seems more. If you're familiar with Java, you already understand how this works, right? This is just a bit confusing because we've got this little token here, this ampersand, right? But in Java, everything's a reference, apart from like the built-in types, fundamental types. But all classes have reference semantics in Java. In C++, we just have to write the references explicitly. Right, so in Java, you might say car C equals new BMW. Right, and then you call c.drive, and it would call the drive method of that class.
we say BMW equals new C, new car. Yeah.
And you might write a method of another class. You might write a method in Java that takes a car as an argument, and you could pass a BMW.
Yeah, of course. Yeah.
So that's exactly what we're saying here. If we wrote a function, if we wrote a method of some other class that took an animal reference, we could pass in a dog, or we could pass in a penguin, or we could pass in a zebra. The only difference is that in C++, we make our use of references explicit with this little and symbol. Whereas in Java, because it's simpler in some respects, the use of references is implicit.
So without the ampersand, A and D would be independent.
Without the ampersand, we'd be creating a new object. This wouldn't be a reference, it would be a fixed object, and that would be, it wouldn't be a dog anymore, it would just be an animal object. And we'd in fact be invoking the animal copy constructor, and we get slicing, and that's a nasty problem, but I'll talk about it.
So you really want to say animal dog. Could you say how you wanted to make A dog?
I'm not following.
You just do. Could you do dog A equals D?
If you wanted to, and that would just.
Yeah, and that would be.
Well, that's what we've done lots of times. That would just be creating a new dog that's a copy of our other dog. If all this is old hat and you understand what this means, I'm not going to go into this too much. But the point is, this is with references. We can do the exact same thing with pointers. And we'd use this syntax instead. So this is saying we've got a pointer to mammal, PM. We're initializing it with the address of D. This is actually, so now PM holds the address of the base class subobject. And we can use that. We can call the mammal member function through that pointer. This idea of base class references seems confusing, so don't worry too much about the base class pointers. But if you feel like you've already got a good handle on pointers, then the fact is, well, just to show you an example, that we can do this via pointers as well.
So it automatically finds a specific bit in the memory that corresponds.
That's exactly what it does. Yes. Yes.
So what does star mean there?
So this means that PM, the type of PM is pointer to mammal. Yeah, don't worry about it. So this is quite a bit to, like I say, we're in the 18th session, right? So this is
It's like an address of the memory.
It's exactly what it is. Yeah. This is saying at this address there exists a mammal. And it just so happens that this mammal is inside a dog object. So this is really the key idea why this inheritance is a useful thing. Is because we have these things called virtual functions, which, well, I'm not sure how much of it we'll get to talk about today. But we have this idea of virtual functions, and virtual functions do something called dynamic dispatch, and it means that we can call the derived class's version of a particular function. So this is runtime polymorphism, as it's called. I'm just going to skip a couple of bits, because otherwise I'm just going to be talking for hours, and I think it's better if you do some work. So let me just skip on a little bit. Okay, let's just talk about this one because it's kind of important. So early on in this course, we talked a lot about value semantics, about using types by value, passing by value to functions. It turns out that using types by value doesn't work very well with inheritance and with polymorphism. We get this thing called slicing. So now I'm going to do very similar to what we did before. I'm going to create a dog. And now I'm going to create an animal. But now this little ampersand is missing. So we're no longer creating a reference to an animal. We're just creating animal. And we're initializing this animal from D. So for those who've been coming to these sessions for a while, what do we think is happening here? Why do I say this is probably not correct? What function is being called here?
Because usually, I mean, D is supposed to be calling the base, the constructor of its base, which is an animal. But now you're doing it another way. You're creating an animal.
Yep, so what's happening here is that this is calling the copy constructor of an animal. A copy constructor, if we remember, takes a reference to another animal. And as we've said, we can pass a dog where we expect an animal reference. So this is a perfectly legal invocation of the copy constructor. So all this does is it copies this base class subobject and creates a new animal using a copy of the base class subobject.
What are the implications of doing that?
What it means is that all we've got now is a copy of the animal bytes that were inside our dog. Right? It means all information about dog, all information about mammal, all information about the other intervening base classes, all that has been discarded. Right? This variable A is not a dog, it's not a mammal, it has no other base classes, it's just an animal. It knows nothing about the base classes anymore. All we've done is create a copy of the animal subobject inside the dog.
Is that the same as saying int f is equal to 5.4, where you slice away the 0.4?
It's actually quite similar. Yeah. So in that instance, what we're doing is we're creating an int from a float, and we're losing information. We're getting rid of all that extra memory.
But if you can you still call it though, and it's just junk?
You'd be able
If
to
you
call
wanted-
a
if you
dot.
wanted to use it.
You could. Well, it's a. Assuming the copy constructor of animal does the right thing, animal is still going to be usable. But the point is, it's only going to be usable as an animal. You can't use it as a dog because it's not a dog anymore. It's just an animal.
So if we look in here, so it's hard. I mean, the A have an I and F, but not S. S will be
Correct.
undefined.
No, not just undefined. Or S just isn't there anymore.
Doesn't
A.
So it isn't there, or is it? It's just random memory that you can call, or you.
The first one, right? So. I'll change the name of these. So we've got struct animal. We're just going to say it has these data members. It doesn't really matter what they represent. And then we've got a dog, which is a kind of animal, and also adds this new data member. When we write this, what we're doing is we're using the animal copy constructor. So if you remember, we haven't written a copy constructor ourselves, but that doesn't mean it hasn't got one. It has got a copy constructor, and the copy constructor will just copy each of the member variables. So when we write this, we're using that animal copy constructor, and we're just copying these things. So A doesn't have a member S at all. A is just an animal, it only has these things.
You can't call it.
No.
So it doesn't make sense why we give it as like a initializer with a D if we don't want to have an S on it.
Well, you wouldn't. This is usually a mistake. It's usually a mistake. That's why I put it up on a slide, because it's a very common mistake to make. It's usually not what you want. Usually you'd want to make this a reference instead.
What if you wrote A equals animal?
A. So you moved this word to the other side of the equal sign. Well, then A is like an undeclared variable. The compiler would say, I don't know what's A supposed to represent. Right, so if you're saying if I just wrote like that, well, here we're using this name A without telling the compiler what it is. Right, we haven't defined what A means.
You couldn't have defined it. Okay.
So when we introduce a variable, we always have to say its type first.
You want to go to some sort of default.
No. We could write auto in there to say I want you to deduce it from the initializer, and then we could put some brackets in here. And that would do the same thing, and now it's very explicit that we're calling the animal copy constructor.
Yes.
Right, so this does exactly the same thing as what I've written there. It's just a bit more explicit about exactly what's going on. So that's probably what you meant when you said, can you just say A?
That's what I was trying to achieve.
Yeah.
Yes.
Yeah.
What if you want to have two? So you want to have maybe animal, like say you have animal, mammal, blah, blah, blah,
Yeah.
and you want three. Would you have animal, comma, mammal? So you want to say A is going to have access to animal and
Well,
another one.
we could do that.
If I want two, so if we have say five, I want to have access to two of them.
Yes, so every mammal is a kind of animal.
She means, I think she means an array of objects.
An array of objects.
I think that's what she means.
Then things get very complicated.
Oh.
Yeah, because you can only have you can't have an array of mixed types in C++, right? So we could have an array of 5 dogs, and then we could create an array of 5 animals and copy each of the animal subobjects. But again, that's probably not what you want. This whole slide, it's called gotchas because this is a mistake. This is almost always a mistake. This is usually not what you want. And it mostly happens if you write a function that takes its argument by value. And when we're dealing with polymorphism, when we're doing this object-oriented style programming, we almost always want to use reference arguments. So that's why Java is all about object-oriented programming. That's why everything in Java is a reference. That's why they don't make you write the little ampersand or the star explicitly. It's taking away this very common mistake of what's called slicing. All right, I'm going to skip this one. Probably talk about it more next week. All this has been lots of me nattering, right? More nattering actually than I intended to do. So sorry about that. But I have got this little example for you. So if you go to this URL, that's actually, it should be 1 line. It's gone up to 2 lines in my slides. But if you go to this URL, you'll find this repository. You can clone it or just check it out as you like. There's a little exercise in there that hopefully will make these ideas a little clearer, or at least give you some practice at using the syntax, give you some practice at how you actually write these things. So again, for those who've been to lots of these, it's the usual deal of check out this project, and the README will tell you what I want you to do. Just a couple of little tasks in there. Hopefully, if I've uploaded it all correctly. If I haven't, then shout and I'll change it. So yeah, this, as I say, it should be all on one line. It's just the slide formatting. Yeah, last week we went through the stuff very quickly last week, so I thought, oh, this week I'll put it in more, go a bit faster, because everyone seemed to have a really good handle on it last week. So now this week I'm going, I've done too much. Yeah, yeah.
I did wonder whether it would be too much to do with the polymorphism.
Yeah, well, I know that. So, but that's what happens. Well, it's not really, because I sort of planned these 4 lessons on the basis of what we're going to cover in the classes. Well, yeah, in a way, last week kind of went better, even though we spent the last 45 minutes not really doing very much.
I think the worst case is if you go the material too quickly, you can always do some exercise.
You can go through the solution
I can go through the solution if you like.
for last.
Oh, for last week's? Yes. Right, has everybody got this URL?
Yes.
Yeah? Okay, so I'm going to take it off the screen. Hopefully someone will have copied and pasted it on the Slack if someone's there. All right, so apparently I don't have the solution to last week's exercise, so I'm just going to do it now while you're doing that.
Are we going to cover like database integration?
We don't have it planned.
Is it-
Do you mean like SQL and
Well, not
things like
necessarily.
that?
Just like because when you have defaults and you had some default values on the int,
Yeah.
that's beautiful. But I mean, real world apps, you'd probably have a connection to a data store.
You might have a connection to a database, yeah.
Yeah.
So,
Just at a theoretical level, like what the code looks like to bring in.
I tell you what, that would probably be quite a good. You know, we're planning on doing these sort of sessions where we just do exercises.
Mhm.
That would probably be quite a good one to do for that. You could do something like interfacing with SQLite or something like that.
Ollie was quite interested. That was one of the subjects
Yeah,
he suggested.
yeah.
Just to go beyond the idea of hard coding, just manually.
Yes, yeah.
Just what the next step looks
So
like.
that's precisely what we're thinking about with the these. What was it going to be, Thursday, or Saturday, or whatever day it was?
The idea is to from 20th of September, yes, we're trying to set those recurring workshops. Basically, somebody more experienced developer will pop in, just pop in to give a hand, and it will hopefully be happening here next to the bar area. So with the one table, so people can sit down and run some exercises from, let's say, Tuesday class. So for example, we cover today this material, so on the Thursday we will try to do exercises about that.
I see. So if I just wanted to Google, try to find something that would help me understand how to code the connection to a database or just some sort of data.
Yeah.
What would be a good reference or resource?
Well, it would sort of depend on what.
Just basically say, I think we were talking about a game. You had a game before with left, right? So let's say someone had created a game.
Mhm.
They had prior results, prior moves.
Yeah.
Right? So a bunch of moves. So that's data.
Yeah.
So how would what would the code look like to bring in the prior history to keep track, say, for example?
Okay, so in that case, you might keep the list of moves in a vector, like in an array,
Yeah.
Which has all the previous moves. So you'd need to kind of decide what data structure you'd want to use for that, what data type,
Okay.
and then you could have. So you might have a vector of moves,
Okay.
and then every time there's a move, you'd call.
The call. That's what I'm interested in.
Yeah, so for a vector, the member function is called pushback, like push something onto the back of this
Have you
array.
tried pushback?
We've talked about vector briefly. We were planning on having a bit more sort of in-depth few sessions, just talking about the standard library classes, like the collection classes, so things like vector and list and map, and all these data types that are come with C++, are built,
Yes.
come with the standard library. So if that's what you're after, then yes, that's definitely something
I think
we're
that's
gonna
what,
cover.
and pushback is a
So it's so vector is one of the collection classes. It's the most common one, the one you probably want to use, and pushback is one of its member functions that pushes a new thing onto the back.
It's a built-in basically.
It comes with your compiler, yeah. It's std : vector,
Okay.
and that's how you add things to the back of an array.
And you use that for like get requests and HTTP calls.
No, you'd need like more specialized classes for.
What's an example of a class?
Okay, so if you wanted to do HTTP requests, you'd need to use a library that knows how to speak HTTP.
Yes.
So there's the one that's very commonly used is called Beast, although it's pretty complicated to use.
Beast.
It is a bit of a beast. I mean, it's very powerful and very, very fast, but it's not simple to get to grips with. Do you know any examples what like an easy to get started HTTP library would be?
Ollie would probably.
Ollie might know, yeah.
There's a Microsoft one. Those open source, but they don't really support them.
No problem. Thanks for coming. Sorry it's been a bit.
It's okay.
Yeah, if we've making your head explode. But come back in 2 weeks' time, and we'll start from the beginning, and things will make a lot more sense. So this thing about declaring variables and all of that will make a lot more sense.
I'm going to shoot off.
Yeah.
This is the first time I've been to a
No
class.
problem. We've got lots of new faces today, which is great.
It's good.
It's just the new faces have come right at the end. So if you want to come back in 2 weeks, that'd be fantastic.
18th, right?
It's 18th. It won't actually be here.
Okay.
But if you go to our website, you can register on there. And we'll have the details of where it is.
Which is
Just the other side of Moorgate Station.
All right, thanks for tonight then. Great.
Cheers.
So next week is
What are you going to ask?
No, 18. Sorry. Hold on. Sorry.
2 weeks from now.
The 4th, which is next week, it's here. The 11th and 18th is at Mimecast, and then we're back on the 25th, and I'm trying to book more classes after that. And from 20th, yes, which is the third week of September, I want to book as well the workshop.
Okay.
So somebody like Tristan, you know, older people.
You want them to fail. You get me the time.
I'll be hosting the on the 3rd, next Monday. I'll be hosting the C++ level.
Probably a better task
Yeah, I'm
rather
good.
than
So I'll basically have an announcement. If they want to
answered all the questions at the beginning.
just to give a hand.
No, he's
The more experienced developers.
No, there was an old, it's so long thread on Meetup. There was an old thread on Meetup. For C++ members, and lots of people want to volunteer to be teachers. If you,
I'll repeat that. So I don't follow that. That was done by Giacomo.
no, the thread I'm talking about, Phil was on it. There was a guy who works for Bloomberg, Italian guy, young guy. There was a young Italian guy who works for Bloomberg. Antonio.
Vittorio Romano.
Yeah. He wanted to volunteer to do.
I remember there was a long time ago something here, but obviously now we have more needs, so maybe people will come forward.
So the way that we define, so what we need first to delineate as so we declare constructor. So we'll define constructor. The way you do that is you class name photo. So you can say portrait picture, colon, portrait picture.
And the explicit is some of the ones
That we only need to put that on the declaration.
Some of the ones that I didn't understand.
Alright.
But anyway,
Yep, perfect. Alright, so first of all you've got to write the derived constructor. So go to the implementation file. You've got to write the constructor at the bottom. You've got to write constructor for that derived file. So what return type do constructors have? Oh, yeah, it's a trick question. So this is actually that's constructor. On the right one for our portrait picture.
Yeah, register on our website. So if you're not yet.
Yeah, perfect.
It is here.
Okay.
18.
It's at Mimecast.
Well,
Maybe you want to tell us.
what do I say? Call it
Shoot,
portrait
check
picture
the
from
comments from our
the
website.
portrait.
So if she does, then she got all the details.
So you're actually the right thing. Alright, so remember we call our base class constructors from the member initializers.
Straight away.
So when we write constructor definition,
Email me. Yes.
before the opening bracket, before the opening brace, we write a colon.
Just put C-line license in the email.
Yeah.
Your name, surname, email address, and I will email you the 6 months license.
Okay, well, first of all, just click run R just to make sure you put that. Oh, in here we're creating a picture. Well, if you change that to portrait picture instead. So just change the type.
When we change it to portrait page to the other venue, we need to go on the website. Their website? No, our site. For here, we go to skills matter. For other places, yes, generally speaking, we do our website. I mean, we're lucky enough, so there are only 2 places most of the time. Here, or mine, which is just up the road.
Is that the code of handling?
Sorry? No. If you go back to the main road, yes, we go over it.
I put that.
Oh, no, get rid of that.
Landlordunion.com. That's our website. And there's RSVP there.
Okay.
I was thinking tomorrow will be open. I think Ollie said that it will be open tomorrow. Just keep an eye on it. Follow me on Twitter. I put as many updates as I can.
No matching function for
How long is the course for start?
Well, depends. We don't have like a set basis. We try to experiment what works better. Yes. So that's the second edition. The first edition we had 26 classes, so basically 26 weeks. This one is 18 weeks. Yes. And we went slower than the previous one, so we're breaking this into smaller chunks. It will be more in a way of covering subjects like a certain part and then jump to the other one, so that allow people join people during somebody feels like, oh, this is too easy, I know that they can have to follow. The people who want that they can join us more frequently. So we're trying to see. We need to figure out the best like a balance, what will deliver the most benefits to you versus the type of the course which we choose.
So baseline 18.
Well, at the moment, this one is 18th, yes. That might vary. That all depends on the class.
So what this is saying is, when you construct a portrait picture, someone passes your file name, I want you to pass that file name on to the picture constructor, a base class constructor. Exactly. Now,
He's my business partner from Poland. He's just visiting.
Oh, nice to meet you.
brilliant. When you go.
One of our first graduate students.
It's a bit of a cheat. Because that's, yeah.
Okay, so the member initializer goes on the definition. Okay, so
I do this, I do C++ for my job. So that's a bit of a cheat.
you normally want to put the definition.
That's doing here like
You want the definition in your CPP.
professionally and unprofessionally challenged and so on. We don't get
Definition of the picture constructor. Definition of this one up here.
I was trying to put it all in the, and that obviously is not that important.
So yeah, also write a definition of that. I'm still writing it.
Okay, sorry. No, just whether you.
I thought I already, because I prepared this exercise like 6 months ago, and I thought I had the solutions, but either I did and I deleted it, or it was just never there. But anyway, so I'm writing it now.
Okay. How are you writing it?
What do you mean?
Is it like AI?
Well, I'm doing the exercise. I just can't. I can't remember.
Sorry, I didn't realize. You told me to.
I just can't remember what I asked people to do. So I'm just having to do the exercise. But unfortunately, migrating everything to this borrowed computer has the compiler settings are a bit funny. I don't know, it's not quite compiling properly. So.
Could you not just replace the hard drive?
Now, until then,
It's a Mac.
Yeah, but wasn't. Oh, you can't. I just thought you could take your hard
Apple don't let you into the inside of their devices. Don't be silly.
This one still you can, but when you have the newer iMacs, they basically use the glue.
You know, this is one of the ones that's everything's glued to the main board. Can't replace the SSD. Can't replace can't replace the memory. Can't replace the battery.
Wants to do something like that.
Yeah, and idiots like me who spend lots of money on computers that break.
They don't break. It just works.
Well, in fairness, mine did work for about 6 years, and then the keyboard broke. But I can't replace the keyboard without replacing the entire main board, which is just more money than it's worth.
It's true for some other laptops as well.
Yeah, I'm not sure the XPS is that much better. You can probably replace the SSD in there. It's probably got a hatch on the back or something. Hasn't it?
Well, I had a problem with the power supply. They sent me a new one. And I had a problem with something else. The audio jack. And they replaced the whole machine.
Oh, well, were you still in warranty?
Yeah.
Oh, okay, well, that's different, isn't it?
Well, but I paid like the extra, I don't know, £20 or whatever it was, and I got accident insurance as well from them. So even if I triple over,
You're the only person in history who's actually made use of an extended warranty.
You trip over one day before expiry.
Yeah.
It was very close to it. Fine. It was close.
I know them yesterday, but tomorrow. If you don't make those models anymore, you can only take the new one.
Look, I was out because the thing is, the USB mini jack was like not working very well.
Yeah.
I was happy for them to just install it, just because it was just a loose, connection.
You didn't mention that you used the hammer to put in the headphones.
If you hover over it, it's cheap. It's all very
Just this, the two things, and it's work.
Hi guys, so it's about 10 more minutes, okay?
Of course.
Thank you.
15. They didn't. They just said, oh, that's an arm sense. Okay, if you
So, here's the point. Look at our classic.
File
name.
themselves, yeah.
So try the variable you're looking for is
One.
It's accessible because it's private. So there are a couple of ways you could do this. A function called getFileName, which, as it happens, already exists. So what I was trying to get at with this, you can't just access the file name directly because it's private to access it. Yeah. So but we have this protected function. Because it's protected, it means that your derived classes can call it. So if in main you tried to call getFileName, it would be an error. But from within the body derived class function, we can call it. No problem. I might just actually do this rather than me sitting here and programming it and then showing it. I might just do it live for people who want to see last week's solution. So if you're interested in what we did last week, I'll go over it now. If you're not interested in last week's, then you can just switch off for about the next 5 or 10 minutes.
Everybody agree.
Yeah. So hopefully my laptop is not going to slow to a crawl now. Right, is this working on the stream? This doesn't look good, does it? Yeah. Oh. Okay, so it's in a very large font. Was the exercise I gave you last week. So there was actually a typo in the README, which is a bit embarrassing, but anyway. It's a file example.hpp. We had a student class. The student had a first name, a last name, and an ID number. And we wrote this in a C style. We just made them publicly accessible members of a struct. And what I wanted you to do was to translate this into a more object-oriented style, writing accessor functions, making the things private, basically increasing its encapsulation. So, oh, this is very slow. I do apologize. This is supposed to be a super powerful laptop that I borrowed, but it's really chugging. So I think because it's having to encode the stream to send to YouTube, but that shouldn't, anyway, whatever. So the first thing was add a constructor taking first, last, and ID variables and assign these to the class's member variables using a member initializer list. So somehow I should be able to.
For whatever reason, still showing. Maybe that's the reason. Maybe it's the
Sorry.
OBS software is having a heart attack.
Okay, is this working now?
Yeah, it's back on my.
Okay, right. I've got 10 minutes to do this. I can do it. So let's look at example.cpp. I've already done this one. So I asked you to create a constructor that takes, I should have called them first, last, and ID. So that's the declaration of our constructor. And then in example.cpp, I've written the definition of this constructor. So let's just give them the names that I told you to give them. Formatted a bit more nicely. So now this is saying our constructor takes 3 arguments, a string called first, a string called last, and an int called ID. And now in our member initializer list, we're initializing our first name member variable with first. We're initializing our last name member variable with last, and we're initializing ID number with ID. So, somebody going to say something? If you've been coming to these sessions, that should be a relatively familiar thing. We've done that a couple of times. Okay, so what was the next thing on the list? Has anybody got this open? Save me trying to navigate through all the things to find the README again.
Add a member function, get first name, which returns the first name field of the student. What should the return type of this function be and why?
Okay, well, maybe someone can tell me what should the return type of this function be? Sorry? Auto. Should it be auto? The answer is no. The trouble with auto is that's going to return a copy of the string. Now, first name is probably not going to be a very long string, but you can imagine if we, generally we want to avoid copying things if possible. So it would be better if we returned a reference. And we don't want people to be able to directly change our member variables. So what we want to return is a const reference. So I think the best return type for this function, oh, go away, is a reference to a const string. Okay, so other than the fact we haven't implemented it, which is why it's yellow, is this a fine definition, a fine declaration for this function? Am I finished? Should it take any parameters? You can put a const on the end, exactly. So this is just the getter. It's not going to modify the function in any way. So we can make it const. What? Yep, so I have. So the first one is talking about the return. This first const is part of the return type. So this is saying this whole first bit here, up to and including the ampersand, which I can't reach, this is the return type of the function. Whereas this const refers to whether we can call this function on a const student. And we want to be able to, we could call the getter on a const student. So let's just write it down here. Can't type. You've got about 2 seconds before C-line catches up with you to tell me what I've done wrong here. I've made a typo. Oh no, typo, I forgot to put something in. Well, get first name doesn't take any parameters. What I've done is I've declared a new function called get first name. What I wanted to do is to say, no, this is the function called get first name that belongs to the student class. And now you see, now C-line is happy.
But you're inside the class.
I wasn't until I typed that student bit. So I flicked to, this is example.cpp. I flicked files. So this is the declaration.
Oh, sorry.
And now I flick to the definition in the other file.
I just left it in the HTTP.
Well, that's
fine. Yeah.
That's also fine to do. So this is what I was aiming for with that question. Get first name, and then I presume I asked you to do get last name and get ID as well, did I? Yeah. Okay, well, we'll skip those because you probably get the idea, and we've only got a couple of minutes left. So get last name and get ID. Did I ask you to do a setter function?
Yeah, set first name member function to allow modifying the first name. And then in set first name to ensure that the name saved to the member variable begins with a capital letter, rather all lowercase letters. Look up S2 upper.
Oh, that was a really nasty thing to ask you to do, wasn't it? Okay. Okay, so we're going to write a new member function called set first name. Doesn't return anything. It's not const because it's modifying the class variables. What argument type do you think I should take? I think. Okay, so I think that's a fine declaration of the function. So let's flick to the other file. No. No, because we have to modify it. So C-line is going to help us out a bit. So now the simple thing to do it's just to do this. So within the body of our function, we're going to set our first name variable to this new name. And this is going to save a copy of new name in our first name variable. But what we actually want to do is to make sure, did I say the first letter is capitalized?
Yeah, then the rest spell it.
Okay, so does it? I can't remember the interface to standard to upper.
You need the standard locale lock.
Oh, I think there are 2 to upper functions. I can't.
I couldn't get it to work.
No.
I might have messed it up. So it was common lock after that.
Oh. So what I was after was something like this. I wanted you to set the first element, that's element number 0, to uppercase, and the others all to lowercase. I don't think I've got this right, but I haven't got time to go through and actually look up the proper function for this. It's not really the key point of the exercise anyway, the 2 upper and 2 lower bit. That was, I think, just to make things more difficult for you. But I wanted you to do something like that. Basically, set the first one. This isn't going to work because we need, or this is a bit dangerous because we need to make sure that new name has at least 1 character before we call this. But anyway, in principle, this is roughly what I wanted you to do. And finally, I think I said change this into a class, right? Yep. And set the access levels appropriately. Okay, so what are the appropriate access levels for these functions? Okay, so do we want the rest of the world to be able to create an instance of a student? I reckon we do. So I reckon student constructor should be public. Do we want people to be able to get the first name and set the first name? So all those things are correct. Now, do we want people to be able to directly access our member variables? No, precisely. Well, would protected be right? Because our set first name, in our set first name, we ensure that we've got this special format. We ensure that we've got a capital followed by lowercase. So if we allowed a derived class to directly change our members by making them public, it would be able to circumvent this. Whereas if we make it private, then even derived classes can't access, right? So what I wanted was this, effectively. I wanted the functions, the constructor and the functions that you've added to be public, and your member variables to be private. This is the usual format. 99% of the time, you want your member data to be private. It didn't run. No, why not?
Because it goes to the main CPP. For me, anyway. The CPP tries to access the first name, last name.
What you'll probably find is that this function here, which is the output stream operator, if we look at the definition, it tries to access first name, last name, and ID number directly. So there are 2 ways to fix that. Firstly is to change this function so we call get first name, get last name, ID number instead. That would be one way to do it. But what I actually wanted you to do was... Okay, this is the very last bit. I just wanted you to make it a friend instead. So write friend, and then the signature of this function. Just like that. So if you made it a friend, it's a friend function, so it can access all of our private classes. Oh, that's not quite right. That needs to be a reference. Yeah, so the friend definition has to go inside the class. So that was what I was after. Anyway, we're being rushed, so gonna have to leave it there. So we'll pick it up next week. And thank you all for coming. And I hope to see you on Tuesday. We're here on Tuesday, or we?
Yeah, we're here next